Hey everyone, welcome to Pyvo after a few months back in our bar. Happy to see quite a lot of you here. Today we have quite an interesting talk, I guess, by Pavol Travnik. Very specific topic, right?
Yeah.
We don't have something like this very often. And it will be about legal judgment prediction using NLPs, correct? The talk will take 20-30 minutes probably. We'll see. After the talk, there's always an open space for your lightning talks if you'd like to speak about anything Python related in a few minutes or so. And yeah, I guess we shall start.
Yes.
Okay.
If you want, you can ask question anytime. Now I will clap just to synchronize my device. Okay, synchronized. And
shall we clap too?
No, maybe after. And you can ask question anytime, you can leave anytime, do whatever you want. So, any lawyers here? Like, hands up? I thought so. Good. PyTorch user, like who is using PyTorch? Okay. Linear algebra basics. Okay. Do you know what's embedding? Like, hands up if you know. Okay, embeddings and cosine similarity. Okay, so it's half-half. Well, so I will provide. For some, it will be a repetition of the knowledge, but it helps. If you are trying to build your own neural network, it's probably the best to use PyTorch. According to papers with Go, like most of the scientists using PyTorch as a tool, so I wanted to start with a simple graph. On the beginning, we will go into more difficult. What was my task when I was doing my master's thesis was when I studied the law. I always wanted to know, like, if I can use programming skills to do something with natural language, and like LLMs came, embeddings, and then I realized, like, oh, maybe this is the right time how I can use it, because, like, you can find on the government page like all the data, like metadata and texts about the decisions, like what was happening, what time, like details about the cases, and which court, which judge was there. It's a very specific topic. This is, for example, you cannot see it actually. It's in Czech, it doesn't matter. And I was like, okay, can I predict how the court will rule based on the data which I can get publicly? And some people tried it, and I don't know anyone who were trying just embeddings to do a classification or prediction. But there is some like meta paper about another work about prediction and classification of the judgments, and they found out that only 7% of the like articles were really predicting the outcome. So you can, if I go back, I don't know if you see the details, but if there is a district court, like Michalovce, like its special town in Slovakia, like they were predicting if the ruling was from there, so it was not basically the prediction. The real prediction is about how it will end, and you will know that basically on the district level. I'll show it. So basically, when the court rules, like district one, you will get the ruling, like in text form, and then attorney has to appeal to another authority, the higher authority, and it will decide if this stands or not. Yeah, it's like is it granted or terminated, denied. So basically, it has 2 or 3 states. What's interesting about the data, like even I had like 4 million documents, like 90% was the drop rate. So basically only 10% of the rulings were held to the appeal, so to the second court, like authority to decide if it is correct. So that's like limiting the space from 4 million documents to just 400,000. Well, I will be just going from the topic to topic because it's like multiple topics which I have to go through. About the LLMs, there is a leaderboard for generating embeddings. I will explain what it is. This is like basically who has the best model now, what are the parameters, like for example, the best for now is from NVIDIA, which has embedding dimensions like 4,000. I will show you how it looks like 1,500 dimensions. In my work I use just 4 embedding models. 2 of them are free and you can download them and use them, and 2 of them are paid. I use this OpenAI small and large because basically they were trained on the Czech language and Slovak language compared to these 2, and they have also bigger input for the tokens, like the words you can put in to get the dimensions. What's the price? Like basically these 2 models you have to run on your server. These to OpenAI you just connect to API, and how much it costs for 500,000 documents. It was pretty cheap, like $3. But if you want to build a search about that, you have to count like every query you are searching for in like when you have Elasticsearch or something, you are trying to search some words, you have to generate embeddings for that to find the best matching document. It's really small. Okay, so you have to believe me, it was $3. Oh my god, this is even smaller. But you get the comprehension how like 1,500 dimension looks like. You have to believe me, this is the first number. Yeah, so this is how it looks like, this multidimensional space. I will explain later. What is cosine similarity? Okay, so if you have like this is 3-dimensional space, okay? So if you have some word which is similar, like robots and plane, like this similarity is really close. Yeah, so these words are similar. So if you want to search something like synonyms and some the sentences which have the same meaning, you can apply this search. This is different than traditional search like Elasticsearch because there is stemming and lemmatization, but with embeddings you can find the words or sentences based on the meaning, not the common meaning, which is very useful. 3Blue 1 Brown had great video about that. I recommend to see that. So in this vector space, like if you are searching for a man and you move in that space in the same way, you will get the similar words as well. This is another example, like you have in vector space, you have countries, and if you move in one direction of the vector space, you can get a capital city. So this is how basically also LLMs memorize things. Well, how to imagine like 1,500 dimensions? It's very difficult. This is probably the most famous toilet. Some of them you know. And if you see these knobs, like these potentiometers, so imagine like the 3 of them are our dimensions. I can imagine always that. So here is the space, and I'm on 0, 0 position. So if I go on one dimension, I will go left. if I turn another knob, I will go back, and if I turn another, I will go up or down. Yeah. So you are moving in that space. So imagine there are like 1,500, and fourth could be like the color of my shirt. So this is how to imagine vector space, like this big. So you can see like there are numbers normalized, like from -1 to 1. And I'm not going to explain this. I love visual representations, but actually okay. Okay. This is cutting my space on here. View slideshow. Maybe we'll see it. Okay, you have to believe me on the top what's written. So cosine similarity here is 0. It's just basically because these vectors are orthogonal to, like, okay, this will help. So they are like perpendicular, like in linear algebra you have fancy word orthogonal. And if, like, these vectors would be very similar. You would see like the calculation would be really close, and if they are opposite, they can be antonyms, very different, they could have very different meaning, or the opposite. Basically, if they are perpendicular, oracle word, they have nothing common at all. Well, as you can see, like the number you can see is the float 32. This is very important when you are training network, because neural network, because less data you have, faster the training is. Like with data, if you have like 1 million not examples, like 1 million rows. It can be fine to use like even float 64, but basically Pythons love 32. Yeah, and if you have a huge database, you even trying to minimize the data type just because to save the space. Training can be faster, but it can be also less precise. Okay, and explain classification. So I'm not sure if it should be equal there, but doesn't matter now. Like for statisticians, this is the basic construction of the formula. Like based on X, you are trying to predict Y. In my case, based on embeddings, I'm trying to find label, or based on the vector, I'm trying to find class. You can see like basically what it means. Like if it is this vector, it should be like 0. And I have a lot of examples. Basically, I have table like with rows of vectors and labels. And the simplest form is like I have text, which is the same in the embedding space like this vector. And if it is like granted, upheld the decision or not. Well, I published data on Hugging Face, so if you want to try run it, you can. About the dataset, what I'm going to share is the mistakes I made, so you don't have to do it as well. Try to learn about the domain you are working with. So, for example, 93% of the academic papers were considered basically just wrong because they didn't know the specific of the domain, like what they were trying to predict. They weren't even predicting. If you have like garbage data, like the most work is based on the creating right data set and clean it, and like it has to be best as possible. You will never find the y. You will never find, or it's not very probable that you will find balanced data set. For example, for me, like when I'm training now the model for Czech courts, like the Constitutional Court denies 97% of cases. So basically, when you have so imbalanced data set, you have no option but you have to put weights there. And you have to calculate the balance accuracy. You have to shuffle data, you have to randomize the rows, and the basics when you are trying to train, you have to have like train, validation and test set, which contains 80% validation 10 and test. This part of the row selected randomly, it will not be training at all. It will not be using even during training for validation. You will use that as the separate example to measure how good is your model. This is simple example how the training works. Basically the curve is going like the loss function is calculated, and on the beginning of the training for neural network, the train loss and validation loss is going together, but at some point the network starts to memorize training data, but validation isn't changing much, so it's best to stop. It's called early stop. So basically you have to cut the training at that point when it brings no more generalization, because it becomes memorization of the training data. This is basically how neural network works. This is input, so imagine like x1 is first number of the embeddings, x2 is second number, so you have like 1500x, and you can have like 3 outputs, like is it category number 0, 1 or 2. Between that you can have like any layers, you can have more layers, more computation. I will not talk about regularization. So when you are training the network, you have like 5 hyperparameters you have to mention, you have to take care of. So we are basically trying to find the best optimal setting for the neural network, and it's the number of hidden dimensions. It's like these two, like how many of them are going to be. How many layers, how many dimensions it will be. It can be like 3000 or just 10. It depends on the network. Some have bottlenecks, some are bigger. Dropout probability, I will not talk about that. A learning rate is like how fast the network, how big steps in vector space the neural network will do. For that you can use Optuna, that's just recommendation. And if you are really like into data collection, no, actually it's smaller. I really recommend MLflow, which looks like this, and you can run experiments and you see like how good they are, and you just select the best model based on the results in MLflow. Okay, that's now the fun part. ROC, like receiver operator characteristics, is like evaluation how good your model is. So basically, if this curve is like this, so it's random, like the model is working like randomly, like selecting like the balls with no value for you, but this model is just perfect. Yeah, like if it's going to be like this curved, so bigger the curve is here, the better the model. And now you can see like the comparison of no, you can't see. I try this one. Okay, so when I started with the prediction, I shuffled the labels just to make sure that neural network works it should, because on randomized data the receiver ROC graph should like this. Yeah, it's totally random, and even the confusion matrix is like it should be on diagonal, but all numbers should be here. It would be perfect model. Well, for when you have chord and I wanted to predict where it will go, the models were perfect basically, because it was easy. Like if you have I don't know, like Prague 1, district court Prague 1, you know it's going to be on these municipal courts, like the Městský soud v Praze. I'm not sure how to translate it. So the higher authority it's going to be, because it was easy to like classify. The open models were much worse than OpenAI. Well, and this is what was really interesting. Like when I put the data in, and I wanted to predict like what's going to be next decision. We have no information how the next court is going to decide, and actually there was a pattern. Like it was much better if you would have like 10 lawyers and they would see the decision, that they would be much worse, like predicting if this case is going to win just based on the decision on the lower or first court. So when I saw this, like, well, there is some pattern which was like amazing. I didn't believe that it will work. I thought it will be totally random. And also like open models found that. So there is some like prediction power in using embeddings. Like you can use it in your field, like if you are working with neural processing and you know the labels, how the outcome is going to be, you can train your own, and in the vector space it will find the minima. No, probably not global, but yes. Okay, and this is also what's interesting. Like if you know Elasticsearch and Quadrant, I wanted to measure how good is to with finding specific texts based on the few words. So I took text, and I was thinking about methodology, how I will proceed. So basically I put into ChatGPT that, well, I will try to make it bigger. This will help. Little. Okay, so I wanted to say like, okay, take this text, this row from the decision, and generate summary for 2 words, 4 words, 8 words, 16, 32, 64, and do a search in a quadrant, which is vector database, and do also search in Elasticsearch based on that. And what was interesting for me, like how it's going to end, like with the performance, and it was, this is after log, okay. So this small notch is actually really huge between these columns. But if you see the big tail, it's doing worse. Even like for 2 words, like quadrant on the right side, it had bigger tail, and it didn't found like 200 texts from 1,000. Yeah, it gets better with the more words. It's getting specific because you can see here, like the text is like long, and it took just 2 words like policejní provokace a aktivní činnost policie směřuje. It's getting more specific and more specific with each word, so it could find the result easier and easier. So here you can see like results for 2 words, 4 words, 8 words. On the right side you have quadrant, on the left side Elasticsearch. The bigger the tail, the worse results. This is for 16 words, 30 to 64. And like I was surprised, like most of them, like Elasticsearch was better, but I must say the summarization did, yeah.
I'm now a little confused. Could you explain what do like x and y axis correspond to on the?
Yeah. Oh, sorry. Yeah, sorry. So x is like x is about when you are trying to search something, you will get 5,000 results. That's fixed. So is it going to be found in 5,000 results, and where is it? This is basically histogram. Sorry for that. Some things are obvious for me, but so this is a histogram. This is like the axis is about 5,000 results, and the count on which position it was. So basically here it is the first, I don't know, like 50 in first 50 results. And this axis y is locked, so basically small change is really huge. It's not visible here, but unlocked was even worse because I couldn't see the tail. But for 8 words, you can see like it's almost finding all words, but in all texts and matching them. While the histogram for like the quadrant, like it didn't found much of them in the first 50 results, but it was spread it in 5,000. So the message is like if you are going to use the RAG in maybe it's not the best. And maybe the Elasticsearch would be better. Some would argue that, well, but especially for Czech, it's not better option, but not so much. But I would probably go for Elasticsearch and try to get results from that after stemming and lemmatization, rather than generating embeddings and trying to search it in vector space. But it has some benefits, like for example, for classification, I couldn't do that without vectorization. So I couldn't predict, basically I could, but it would be much more difficult to train a neural network without embeddings. It helped a lot. So is it clear?
Yes.
At least I can repeat it. And one of the really nice things, if you have redundant data, and it happens a lot, you can just with minhash just read of them. It's really nice tool when you have like text which are repeating, you just delete these repeated words and and you can set up the threshold. So for example, if I wanted to delete, like you can see it's not linear, so you have to try to run thresholds. For example, if you want to read of like 30% of data, the threshold 0.46 would be perfect. So total number of documents was the rows were 400,000, and if I wanted to reduce data for training, because you basically, if you train it on the same data, it doesn't make sense. You just wasting resources. For small data sets, it's probably too much work. But anyway, like for bigger data sets, you are trying to get as many redundant data as possible, maybe even zero. When I try to, this is what will become interesting, when I try to train neural network with a threshold like 0.55, which is basically half of the data, like it got the same results with balanced accuracy. So what's the main idea here? What I'm trying to say first topic was in predicting outcomes based on the embeddings is possible. Like I didn't think so. I didn't thought so until I did it. And the second idea is that Elasticsearch, I thought it's going to perform like not really good, and it was performing actually surprisingly well compared to Quadrant and vector search, which can be quite expensive when you run it for a company with multiple, like people are querying that. So here you can connect me. I recommend you follow Andrej Karpaty if you are interested in LLMs. 3 Blue 1 Brown on Pyvo in Prague. There is Pavel Kral, I think. This is his LinkedIn. He's interested in LLMs. This is just because I saw his presentations and it was really nice. And this is my LinkedIn and Nostr, so I think I will stop here. Any questions? Yeah.
I would like to understand what you're putting in the neural network. Like when you have the document, the judgment, I assume there are like hundreds of words or maybe a few thousand of words. When you like call the OpenAI API, then you get like one vector for each word. Is that right?
Yeah, that's not for words. That's how LLM works when it's doing that. I don't know this much. It's doing the inference and it's actually responding you with the actual answer. But what I'm putting in is the input is tokens. So basically, if you have word like umbrella, it splits words on the tokens. It's like syllables like umbrella. It depends on the tokenizer, and there is maximal input you can put there. And the output is vector. So basically what I had to do is like the document has different length, so it can have like much more words than there is input that allows. So we have to cut it, put just the input you are allowed, you get a vector, and another part, vector, another part, vector, another part, vector. And you have array of vectors, and then there is operation average pooling. So for each dimension, it will average the value, and you will get just one vector, which is based on all the multiple vectors. So basically, the input space for neural network is the same, but you've got array of vectors first.
Yeah.
So you are limited with the input space of the model, and you can see like the free models have limitation like 512 tokens, which is quite small. It's I don't know 12 sentences, and OpenAI can handle much more. It's I don't know. It's probably 2 A4 pages, which is fine, but if the text is longer, it will just cut it. So you have to like average that or do another operations, like it's possible also. But I did averaging.
Thank you.
Můžete se i česky ptát. Okay.
Would you say that the quality of the prediction is correlated with the population size of the country? Because like I'm thinking like if you take like different countries, you can't really use data from two different countries because they have different law.
Well, that's the like this was the point of the presentation. Like you basically can take any data you want.
Yeah.
So you go. Now I'm doing it in Czech Republic, and like if you have public data set, like you download the data, process it, clean it, and you will run it. You will basically get like I thought it will be random, and it was some pattern. It was also in Czech Republic. I ran another model in Czech Republic. It was again like 0.6. Maybe some of you have experienced. Maybe it's a bug, but I tried it multiple times. I spent like basically months trying to find the bug there, and it still outputs around 0.6. So the balanced accuracy was like 50%, but it's for 3 classes. So you have to imagine that like you have for 2 classes it would be probably 70% or 65%, just guessing. So but you can come to any country, take the data set, and you can predict the outcome, and that's quite weird because you shouldn't be able to do that. Yeah, like I don't know what's going on, like it can be the name of the judge, it can be the topic of the decision, it can be like, I cannot untrace it back because I don't know how the embeddings are created, but there is something, some information in the embeddings having it. And what I'm trying to say, like this is about the public data set, like emergent situation, and it's in basically in the work, like if the government would take all the documents in the file, which can be quite huge, digitalize, create embeddings, create neural networks on a huge data set, because like final decision is just small percentage of the data in file. So based on that, I think the accuracy would be even better. Yeah, because it can be like it can be information about how the attorney is good, because the neural network can see like, oh, this embedding is probably like about this lawyer, and like he's doing well, and this one is doing not good, and well, I will go like this will be granted because of that, but I actually don't know what's the essence why it decides this way.
Yes. To give you a bit of context, I'm from Brazil.
Yeah.
And we are, I would say, like at least 20 times bigger than Czech Republic in population. Yeah. But then like we have one single like group of laws that goes like countrywide. And I have a friend which is in Python and IT, and he's a lawyer as well. And we were talking about this like 2-3 years ago, and he was like, "Wouldn't it be nice to process all the data?" And he has been collecting all the data in the public portals.
But you should run it. Like I don't know about like Slovak Republic has 5.5 million citizens, and it has 4 million decisions online. Yeah. After cleaning, it was because I had to read a lot of them, so it ended up on probably 40,000 decisions, not much, but I could train the network to find the pattern. But if you have like huge data sets and metadata there, like basically you can train it you see the results. But the dataset has to be public. Yeah, probably I don't know how the browser if it is giving the data online or not about the decisions.
Yeah, we have a lot of push for open data.
Yeah, okay, cool. Should be that.
Můžu vlastně česky, že? No, tak je to už nějakou chvíli, co jsem dělal strojové učení, ale přijde mi teda, že ta accuracy, jo, a ty celkově ty výsledky, že to není jako moc, ne?
Okay, můžu odpovědět? Okay. So the question was like the accuracy is not something like really good. That's why it's not like huge wow, and I'm not on Forbes. but for 3 classes, the basic accuracy, like don't look at the accuracy on the first because I'll explain. If you have imbalanced data set and all labels will be in one column, like everything will be predicted as 0, then you can have accuracy 90%, basically just because like zeros were 90% in the data set, and neural network learned to predict everything with 0. So accuracy is 90%. But if you have balanced accuracy, it's trying to match it with the weights. So this is actually the right number. And the thing is, like, if you have 3 classes, like 0, 1, and 2, the base is 0.33. So if you have accuracy 0.5, it's starting to be like quite, it's not perfect, yeah, it's like nothing spectacular, but you see the pattern. Usually when you are studying biology or anything, the ROC curve, like when it's really good, it goes like this, yeah. Oh, I actually, yeah, this is like the almost perfect example, like it's predicting everything on the diagonal. I'll show it bigger. Sorry. Once more. Okay, what's going on? Okay, and file. Okay, so if everything is on diagonal, it should be like it should be 0, and it was 0, so it's on diagonal. And if you see blue line there, like most of the values on diagonal, it's perfect. But with 3 classes, you have to count like it's not actually bad. Yeah, it's like it's really a pattern there. And when I started to work on that, I really thought it will be totally random. So it will be. Sorry.
Ale jakože na nějakém datasetu jste měl tady ty super výsledky a
okay.
Na jiném jako to dopadlo.
This is actually not prediction. This is classification. So when I had a judgment, I wanted to predict which court it will be appealed. So, že jaký bude odvolací soud. But it can be the information can be in the text. So you know, if some court is near Brno and the appeal court is in Krajský soud v Brně, I'm not sure. In Brno, so it will measure like, okay, it's easy for me to train because in vector space it's close. But in some cases, like how judge decided, it can be like you cannot put every information about vector space. I had limited information from the public decision. It could be bright there, yeah. It could be any possible event which you cannot predict. If you don't have data, you cannot predict why without it. If I would have data about maybe about the income of the judges, all their property. I could put the bribe, and maybe it would be like little bigger, but I don't think in Czech Republic it would
So
be.
maybe possibly have you tried to like segment somehow the data, like keep just the občanskoprávní spory?
Yeah, it's in a master thesis. Yeah, like you download it. Where is it on the beginning? Okay. Yeah, here. There is also prediction like is it going to be criminal law or civil law? I can predict it easily because it's this label, like it can easily learn that it's civil law because it's about divorce, and it's criminal because it's about like robbery. But prediction of the next court, that was the question, and that should be random, and it's not. I don't know why. And that's wow.
Okay, one last question maybe?
I have a question. The model was trained on actual judgments, or was there actual law text?
Oh, well, good question. We have to divide like two things. LLMs. I'll probably. I'll not show it. I'll explain it. LLMs. That's based like the technology of transformers. When you write, it interacts like computes, and it starts to predict next token, and this is what you see how it's responding. Yeah. And this is LLMs. Embedding models, you will put text there and it will respond vectors. This, like some of new LLMs doesn't have this embedder. They basically compute it, but there are two things you have to like split. Even OpenAI offers you like chatbots and embeddings. So if you want to, simple example, if you want to respond give me tips for vacation, you will go to chatbot and it will respond with text. Embeddings, on the other hand, will do like, you will put their text and we will respond with a vector, and you can make a classification, some analysis. So that's why it was interesting that the text is converted to this vector space, and you can make statistical like operation like principal component analysis, classification, etc. So, but with embeddings you get vectors. That's nothing meaningful for you as a person, but for statistic purposes and computation, and see how the data what connections have data, like you are trying to find the correlation, etc. Basically they have like, I show you, open and AI and embeddings. Well, yeah, so here is what you can do, like text search.
Jenom já zkusím český. Možná jsem se zeptal blbě anglicky, já jsem se ptal, jestli ten model, nebo jestli vůbec šlo o nějaký trénink modelů, a jestli ten model byl trénovaný na rozsudcích, to znamená na anebo na textech.
OK. Takže byly embeddings a ty embeddings byly input pro nový neural network a ten model byl trénován jenom na těch embeddings. Takže embeddings měly 1500 dimenzí, to šlo do toho neural modelu v PyTorch a output byly 3 klasy a já jsem si definoval, jak velký má být ten model, kolik layers, hidden space, regularization, etc. A snažil jsem se najít, že jaký tvar toho modelu bude jakoby nejlepší pro to.
Jestli můžu doplnit, já si myslím, že kolega se ptal na to, jestli to bylo jako trénované jenom jakoby na judikatuře, jako na rozsudcích soudů, nebo jako jestli i na znění zákona.
Jenom na těch embeddings z těch rozhodnutí.
Jo. No,
tak.
Takže to nějakým způsobem nereflektuje třeba nový zákony, na který ještě nebyl rozhodnut.
No to třeba tak jako novely, že?
No.
Můžu
tam je ten text je jenom, co ty soudy jako
to je to domain specific knowledge, že vlastně u rozhodnutí tam je nějaký text a máš k tomu jakoby label, jestli tomu bylo vyhověno, zamítnuto a tak dále. Ale když ti přijde novela, tak ten jako alebo se změní zákon a tak dále, tak ten jako ty nemáš jakoby input pro jakoby to ani label, to je vlastně jako úplně jako separate text, to je jako kdybys vlastně chtěl klasifikovat, že máš rozhodnutí labels a někde proběhl plavecký zápas, jakože ono to tam, teda, že nějaké vodní polo, jo, a byly tam nějaké výsledky, jo, to jako, prostě není tam connection mezi tím, jak je schválen. Ono to je vidět na tom například, že některé zákony se v podstatě i ruší, jo, a že jsou, jo, takže jako kdyby byl zákon a měl nějakou label, tak já můžu vzít sbírku těch zákonů, těch novel a tak dále a pak přiřadit tu novelu, například jestli bude schválen ten zákon. Jo, to by byl dobrý case. Že teď já vyberu celou sbírku ze sněmovny návrhy zákonu, vemu ty texty a budu predikovat vlastně, jak dopadne. A když někdo podá nějaký poslanecký návrh, dneska podají návrh a přijde tam PDF-ko a já si to hodím do modelu, tak mně vyjde jako pravděpodobnost, jestli to schválí nebo ne. Ale musím porovnávat stejný se stejným. Nemůžu jakoby vzít rozsudky a míchat to jakoby se zákonama. Jako pro klasifikaci.
Můžu být k tomu takový doplňující, když budeme se bavit jenom o těch rozsudcích, ale já si myslím, že tam je jakoby diskutabilní, za jakou dobu si to bral, protože ono se může stát, že prostě třeba 5 let sází soudy obecně nějaké rozsudky, pak dejme tomu nejvyšší soud, se na to pořádně podívá, hodí nějaký rozsudek do judikatury vlastně, které jakoby to převáží, ty soudy by k tomu měly přihlížet, že jo, není to dané jako, že by museli, ale jakoby je to jako taková převáha. A dalších 5 let budou teda rozsudky na základě toho, že nejvyšší soud rozhodne nějak jinak. Takže ty tady budeš mít 10 let nějaký interval, 5 let soudy rozhodují nějak, potom nejvyšší soud dá rozsudek trošku, dejme tomu, subjektivně vyšší síly a na základě toho budou dalších 5 let ty soudy soudit podle toho doporučení toho nejvyššího soudu. Takže tady máš 2 opačné strany a jaká strana je vlastně ta správná, protože každá strana je poplatná své době, jo, vlastně. No. Tady nejde říct, jestli potom ten tvůj model, když rozhodne nějak, jestli se trefil, nebo netrefil.
Na to dám jednoduchou asi odpověď, že proto může být jako nižší performance toho modelu, to je první věc. A že vlastně, že kdyby právo bylo stabilní, tak jako ve Švýcarsku, tak bychom měli jako hezčí tu křivku a bylo by to předvídatelnější. Možná, že tak by se dalo měřit i předvídatelnost práva, že když to padá, tak je to špatně. A druhá odpověď je, že my se bavíme, že když se dělají jakoby benchmarky na modely, tak se tam dají nějaké jakoby tasky a žádný z těch, když se podíváme na MBPE, ten benchmark for classification, který vypadá takhle, se dlouho načítá. Tak ty scores, jako oni se předbíhají, který bude jakoby jako lepší, jo? Ale to není na 100%, jo? Že dejme tomu, kdybychom brali, jak zkoumali prostě šedý zákal, teda žlutý zákal, myslím, a predikovali ho na 10 let dopředu, tak to byl biologický proces, který se neměnil a může se to nějak generalizovat, jo? Právo OK je nějaký asi biologický proces, ale i ty tasky, které jsou na ty embeddings pro jako benchmarky, jako klasifikace a tak dále, tak oni nemají 100%, jo, úspěšnost. A to samé je, jako, to je taková myšlenka, kterou bych jako posunul, že neural networks nejsou od toho, aby dodávali 100% accuracy. Jo, tak je to samé, jako když přijdete k lékaři a diagnostikuje rakovinu, má nějaké marky, a taky to není 100%. Je to jako zase bias rule, že máš příznaky a zároveň máš ty marky, tak na 90% máš tu rakovinu a proto zahaj. Jo, tam to není jako, že boolean, jo, že true, false. A to bych chtěl jako říct, že vlastně když i někdo po mně jakoby přijde z neural network, tak my teď běžíme jakoby závod, že kdo bude lepší. A jako když někdo přijde s modelem, který dokáže odhalit, OK, ale v tomhle rozsudku je změna, a aktuální moderní pravidlo je, že se to vysvětluje tak, poslední 2 roky, takže tvůj model bude horší, tak tehdy jako můžu říct OK, tak teď si to udělal fakt dobře, že ale jako, ale to musí někdo naprogramovat, jo? To tam musí jako, že to je zase delikátní jako odbočka od toho a ten model se víc zase specializuje. Takže někdo to musí naprogramovat, aby to bylo ještě lepší a mělo lepší výsledky.
Mně napadá jenom taková věc, nevím, jak moc by to bylo těžké nebo ne, jako by těm rozsudkům, které jsou jako aktuálnější, dává větší váhu než nějaký, které 10 let. Prostě,
a může to být takhle jednoduchý, jo, že se tam změní ta váha. Jo.
Těmi vstupními daty jsou texty rozsudků.
Jo.
A nemělo by to být radši texty žalob?
Mělo. A proto já jsem udělal to, že je rozsudek a já nepředpovídám z toho, ale z toho, jak rozhodne ten soud nad ním. To znamená, já beru jenom text rozhodnutí prvního stupně a výsledek ty odvolačky.
Jo.
Protože já nemám přístup k těm žalobám, jo, to má jenom ministerstvo. A proto jsem říkal,
ale ten soud to tam stručně zopakuje vlastně.
Jo, ale podle sebe. Jo, jako, nevím, jestli se prošli jednáním, ale je to dost takový jako jiný, jo. To není jako nic s matematikou, nic jako, ale říkám, ministerstvo, když všechny ty data dá z toho failu do toho, tak jako teoreticky by mohlo udělat model, který bude mít accuracy 80-85%, jo. A nikdo ho nebítne, protože vlastně má ty data, jo, že, takže it's possible.
Já bych ještě měl poznámku k tomu míchání vlastně těch rozsudků a zákonů.
Jo.
Že vlastně v tom rozsudku určitě budou odkazy na ty zákony, jo? Že podle paragrafu tolik a tolik, jo? A tím vlastně je tam odkaz, tím tam může do toho modelu se zahrnout text toho zákonu a v podstatě, když to bude mít dostatečný počet parametrů a budou v tom texty těch zákonů a všechno a já tam zahrnu texty nových zákonů a ten model do toho doučím, tak by v podstatě jako tam mohla být nějaká vazba, mohli by to dělat nějaký
oni se jako jsem četl články předtím, oni se snažili dělat i legal reasoning, což nevím, jestli je oxymoron, ale to byl vtip, tak it's funny because it's true. A jakože snažili se tam dělat legal reasoning a přesně jako pracovat s LLMs, ne tímhle, že to dali do vektoru, ale na základě tokenu, že jestli jsou tam ty pravidla dodržený, ale jak když jsem viděl jakoby reálně, jak to probíhá, tak to je jakože tam jako bych nehledal reasoning, to je jakože prostě která buňka se pohla doleva, která doprava, jo, že podle mě je lepší jako udělat image, jo, nějaký, dejme tomu kůže a prostě a nechat to spočítat a moc nad tím nepřemýšlet, že spíš mít hodně jakoby obrázků jako toho, že co je rakovina a co není, jako znamenka a udělat co nejvíc a jako nesnažit se to naprogramovat. Ono to bylo vlastně i s učením překladu, že oni si mysleli, že naprogramují jako jazyk překlad a pak se ukázalo, že vlastně ty deep neural networks, které vlastně se učili, tak byly lepší. Jo? Že dáš tomu data, co nejvíc dát, možná jakože i ty zákupy, já nevím, jak bys to propojoval, ale
aby se taky učili ty neuronové sítě, oni by si, tam by opravdu byl odkaz na ten zákon a ta neuronová síť by se učila jako i na ten textu toho zákonu, jo, a dala by si vazbu, že tady byla vazba na ten rozsudek.
Jako, pak mi to můžeš přijít ukázat. Jakože já jsem si to představil a jakože když jsem si představil tu práci, tak jsem byl takový, že že už jenom vlastně se sbírat ty data, vyčistit to bylo úplně, že jako aby to pasovalo, aby tam nebyla chyba, tak to bylo insane, že bych to ještě napároval. Tak to, co chci teď udělat, je, že vyextrahuju jakoby jména advokátů z toho a pak udělím jako asi cenu a malinu těm, kteří jsou nejlepší a nejhorší, jo, ale to tak asi všechno, co teď zvládnu.
Right, folks, if you have more questions for Pavol, I guess you'll stay for a while,
Yeah,
right?
yeah.
Okay, so you can, I guess there will be a lot of discussion even after the talk. I'd like to ask if there are any lightning talks. Anyone would like to speak? Please,
Yes.
right? Anyone else?
Yeah.
Okay. So I guess we'll do a little break, 10 minutes, and I'd like to also speak a bit. The four of us. If there's more, you're welcome on the stage for a few minutes to speak about anything Python related. All of those are Python related?
Yeah.
Okay, cool. All right. So back in 10 minutes and we can start the lightning talks very quickly.